Chapter 13, in-class exercise 3, cylindrical coordinates. Problem 1389. The boy of mass 40 kg is sliding down the spiral slide at a constant speed. See, remember, this is very important word, constant speed. That means there is no acceleration, such that his position measured from the top of the chute has components. R is 1.5 meters. Theta is function of time, which is 0.7 t radians, and z is minus 0.5 t meters. It's negative because z-axis is positive going up, where t is in seconds. Determine the components of f, r, f theta, and fz, which the slide exerts on him at the instant time t is 2 seconds. Neglect the size of the boy. So this last statement, neglect the size of the boy, indicates that consider the boy as a particle and not a rigid body. Okay, so let's work on this problem. So first step is we will use these equations here, sum of forces in radial, transverse, and z direction, and corresponding acceleration equations are given here. So these are from chapter 12. So this is called radial acceleration. This is a theta, and this is az. So these are three equations for our acceleration. Oh, there is typo here. This should be negative, not positive. Yes, so define the coordinate system. So this direction is radial direction measured from the center of the axis. Perpendicular to radial is transverse direction along the direction of motion. And this is z direction, which is the vertical direction of the motion. So these are the positive direction for our coordinate system, r, theta, and z. Now the force that boy experiences is the normal force acting from the slide onto his body. This normal force we will resolve into three components. That is, component of normal force along radial direction, we call it Fr. Component of normal force along transverse direction, we call it F theta. And component of normal force in z direction, we call this Fz. So these are the three components of normal force. So we will not draw the normal force, but we will divide that into three components. Yes. And the only force that acts other than those components is the weight of the boy, which acts vertically downward. So W equal to mg. So if we draw a free body diagram for this boy, it will look like this. So weight, which is m, first of all, three axes, radial, transverse, and z. Fr, F theta, and Fz are three components of normal force. So normal force is resolved into radial, transverse, and z. So these are the three components of normal force. And then there is a weight force here. So that's our free body diagram. And corresponding kinetic diagram for this situation will be, we draw this boy here and indicate three accelerations. So acceleration in radial direction, acceleration in transverse direction, and acceleration in z direction. Okay, so this is FBD, and this is corresponding kinetic diagram. So let's solve the problem. What we have been given is radius is 1.5 meters, which is constant. We know theta, which is 0.70, and z, which is minus 0.5 t. Now, in order to calculate different components of acceleration as shown here, we need to calculate r, r dot, r double dot. So value of r is 1.5, and that is constant. It is not function of time. So if we take the derivative, we get 0. If we take another derivative, we get 0. Theta is 0.7t. So theta dot is 0.7, and derivative of constant is 0. Z, on the other hand, is minus 0.5t, Z dot is minus zero point 0.5 and Z double dot is 0. Now, where we have t in our equation, we will apply all calculations at t equal to 2 seconds because that is what we have been asked to do in the problem. So let's apply these equations of motion. Sum of forces in radial direction is equal to mass time radial acceleration. Now, there is only one force in the radial direction, which is Fr, radial component of the normal force is equal to mass times. This is the equation for radial acceleration, which is R double dot minus R theta dot square. So we can substitute values here. 40 kilogram, R double dot is 0, R is 1.5, and theta dot is 0.7 square. So we get negative number here, which is minus 29.4 newtons. Don't worry if you get the negative number. What it simply means that this component of the force Fr is not along positive R direction, but it's along negative R direction. When we get negative number, it means that it's acting in the negative direction. Now, second force is sum of force along transverse direction is equal to m 8 theta, and where m 8 theta is given by r theta double dot minus 2 r dot theta dot. And there is only one force along this direction, which is F theta. And when we substitute all the numbers here, that 40 kilogram radius is 1.5, theta double dot is 0, 2 r dot is 0, and theta dot is 0.7. So this is actually 0 minus 0. So 0 multiplied by 40 is 0. F theta is 0. What it means that there is no normal force along the theta direction, which is the direction the boy is sliding. And that makes sense because this is the direction he's sliding and there is no opposing force. Last sum of forces in z direction is equal to m times z double dot. And z double dot is 0, so this is m times 0. However, there are two forces here, Fz minus mg, because weight acts in the vertical direction along with the Fz force. So Fz is upward, but the weight is downward, so it's negative. That means Fz is equal to mg, just moves on the other side. Then that's 392.4, which is 40 multiplied by 9.81 newtons Fz. Okay, so these are three components of the normal force that we have solved for: Fr, F theta, and Fc.